let us talk about sequential form games. But before we talk about sequential form games, let us also talk about one game, Battle of Sexes, and then we will convert this game into a sequential form game, right? So there are two individuals, one girl S and one boy H. Girl likes to go to Starbucks and boy likes to go to local latte, right? So, but both of them will be getting the utility if both of them go together, right? If they go separately, that is, girl goes to her place of choice, boy goes to his place of choice, they will not be getting any utility at all. Means, for example, if boy goes to local latte, right, and she goes to Starbucks, both of them are going to get zero. So they want to go together. That's an issue, right? Okay. Let's look at the game first, just a normal form game, your matrix method. So supposedly, if S chooses LL, hmm, then boy has a choice between LL and SB. So he has a choice between 2 and 0. Of course, he'll be choosing 2. Let me use the another pen. He has a choice between this. So he'll be choosing this too. If boy chooses LL, girl has a choice between local latte and Starbucks. So she's comparing 1 and 0. She will be taking up 1. So this is 1 Nash equilibrium. Well, if she chooses Starbucks, then boy has a choice between local latte and Starbucks. So he's comparing 0 and 1. Of course, he'll pick up this. If boy chooses Starbucks, she has a choice between local latte and Starbucks. So she's comparing 0 and 2. And of course, she is going to choose 2. It's going to be like this. Right, beta? So there are two Nash equilibriums, right? In the normal form game, in the matrix method, there are two Nash equilibria. There are two Nash equilibria. One is LL, right? And SPSP. Hmm? Up until now, there is no problem at all. So the only thing is that this normal form, this matrix method, it can only represent the situations in which people are moving simultaneously. There's no concept of time out here. Uh, So you're not talking about whether girl is moving first and then boy is deciding, or boy is moving first and then girl is deciding. This is not what you are doing. So please write this in normal form games. In normal form games, right? Only those situations are represented where people move simultaneously, right? So there is no sequential nature of the game. So it's not that who is moving first. There is no concept of time out there. But there are many situations in which the sequence is going to be playing their part. So there can be the cases where players can choose their actions sequentially, that is over time, rather than simultaneously. Rather than simultaneously. So in many situations, players chose actions sequentially over time. Hmm? Sequentially over time rather than simultaneously. So you need games in the extensive form. So these extensive form games are also called sequential form games. These extensive form games are also called this sequential form games. So let me just convert this game into a sequential form game, right? So let us say girl is moving first, right? So she is moving first, and maybe she gives a call that she is going to this place or that place, and boy knows that wherever she goes, he has to follow, because if he goes to the place of his choice, then no, nothing could be done, because neither she will get any utility nor he will get any utility, right? So what will happen? So girl has two choices. So she's the first player and she is moving first. She has two choices. She can go to local latte or she can go to Starbucks, right? Then boy comes. He also has two choices. At each node, he also has two choices. He can also, I mean, even if she goes to Starbucks, he has a choice of going to Starbucks or local latte. Or if she goes to local latte, then also he has a choice of going to local latte or Starbucks, wherever. So if he goes to local latte, Starbucks, local latte, Starbucks, right? Okay, now think about it. Just just think about it. If she goes to local latte and he also goes to local latte, then the payoffs are 1 2, right? If she goes to local latte but he goes to Starbucks, so if she goes to local latte but he goes to Starbucks, neither of them is going to get any payoff. If she goes to Starbucks but he goes to local latte, so she goes to Starbucks and he goes to his place of choice, again nobody is going to get any utility. If she goes to Starbucks and he also goes to Starbucks, then this is what she's going to get as the utility. Now, before solving the game, now think about it. Before solving the game, there are a few things which you have to understand. This is what is called the game tree. This entire thing which you have just drawn. This is what is called the game tree. And in every game tree, you need to tell who are the players, right? So here the players are S and H. These are the two players. So this is the initial node, this is the non-terminal node, and these are the terminal nodes, right? These are the terminal node. So this extensive form game, it specifies the following. It specifies this: the players of a game. It has to tell who are the players of the game. Right? Uh, for every player, every opportunity they have to move, right? That is, at this node, she has two choices. If the game moves to this node, then boy has two choices. If game moves to this node, then boy has two choices. So For every player, every opportunity has to be told. For every player, every opportunity. They have to move. Every opportunity they have to move, right? What each player can do at each node. So, I mean, she can go to LL, she can go to SB, she can go to local latte, she can go to Starbucks. So, what every player can do at each node, right? What each player can do at each of their, at each of their nodes, right? What each player knows, I mean, at each node. For example, H knows here that she has moved to local latte. H knows here that she has moved to Starbucks. She knows here that there is no history before her. So she is the one who is starting the game. What each player knows for every move. Knows for every move. What each player knows of every move. And what are the payoffs received by each of these players at all the outcomes, right? So the payoffs received by every player for every possible combination. For every possible combination of moves. So the sequential form game has to specify all of them. It has to specify who are the player, what what are the opportunities available to each player, what each player can do at each of these nodes, what each player knows at each of these nodes, and what are the payoffs, right? What are the payoff? Uh, so these non-terminal nodes, right? So here, these are the no see guys, these are the terminal nodes. Terminal nodes means game is going to end here. These are the non-terminal nodes. Other nodes are non-terminal nodes, right? This is non-terminal node, this is non-terminal node, and the letter which is telling you at these non-terminal nodes, this is indicating I mean, who is the player who is sitting at that node, right? So, and these numbers, these are the payoffs. These are the payoffs. So the first one is for the player who is moving first. Second one is for the one who's moving second, right? Player one, player two, right? So this is what it is. Just the simple game. Uh, Now again, come back. So it is telling you what? It is telling you the list of the players, the actions which these player can take, what information these players have at each stage of the game, and what are the payoffs, right? What are the player payoffs? So now just think about it. Now just think about it. So what is going to be the Nash equilibrium of this game? Hmm. So if let us just solve it using backward integration. Okay, before than that also, if she chooses LL, let's say, if she chooses LL, then he has a choice between choosing 2 and 0. So of course he'll choose 2, right? He will choose 2. If she chooses SB Starbucks, then he has a choice between LL and SB, that is between 0 and 1. He will be choosing 1, right? He'll be choosing 1. So in that case, so you have 1 2 from here and 2 1 from here. Now she has a choice between 1 and 2, so she'll be choosing 2, right? Okay, you can think of using the backward induction. You can just solve the game using backward induction. That is, what is going to be the answer to the game if you're going to solve it from the end of the game. So supposedly if you are at this node and player H has to choose. So player H has to choose between local latte and Starbucks at this node, right? So he's comparing 0 and 1. So what is it that he will be choosing? 1 now. He'll be choosing 1. So this is the winning node. So I can write, let's say, this becomes the payoff for this node, right? SB node. Now, between if he's sitting at this particular node, let's say, then he has to compare between 2 and 0. He has to compare between 2 and 0. So think about it. What will he choose? He will choose 2. Huh? So this is the winning node. This is 1, 2. Now then player S has to choose between 1 and 2. What is it that she will be choosing? She'll be choosing this between this 1 and this 2. She'll be choosing 2. So this is what she's going to choose, right? So what happens? What happens? That is LL still a plausible Nash equilibrium? No. So your Nash equilibrium is now SB in the sequential form. So she is going to choose Starbucks and he is only going to follow her. This LLLL, which you got in the simultaneous move game, this is no longer a plausible Nash equilibrium, right? So what you can write like this, that S chooses Starbucks and H follows. And H follows. So the outcome of the game would be what? Starbucks. Hmm. The other Nash equilibria which you have got in the simultaneous move game is not a plausible equilibrium. The other Nash equilibria, that is LLLL, is no longer plausible. So she knows that if she has to choose Starbucks, I mean, his only choice is to follow her. That is the only thing, right? And can can you just think about it like this? Can this boy tells this girl, by whatever you do, I will choose local latte only. Hmm? Can he commit? Can Because in case if she goes to local latte, he has no problem to go to local latte. But if she goes to Starbucks and he wants to go to local latte, so can he commit? Can he commit that if you choose Starbucks, I will be going to local latte? Can he commit that? No, he can't. This is an incredible threat. That's a non-credible threat. Huh? Because If he chose to go to Starbucks, he will be getting 1. If he chose to go to local latte, he'll be getting 0. So why would he do that? He will not do that. So please write this. H cannot commit to go to local latte, right? If S chooses Starbucks, right? His best response is to follow. His best response is to follow. Are you with me? Are you getting what I'm trying to say? Can he threaten her? Can he threaten her that, boss, if you chose Starbucks, I will choose local latte? Can he threaten her? I mean, she will say, fine, go. Because fine, I will be getting 0. Means she will tell him, fine, if I go to Starbucks and you go to local latte, I will be getting 0. This is what she is saying. But you, means H, this boy, will also be getting 0. While in case if you chose to come to Starbucks with me, you will be rather getting 1. So the threat which you are giving me is a non-credible threat, right? Is a non-credible threat. Are you with me, beta? Hmm? You with me? Right? So this is what a very simple idea of the extensive form games or the sequential form games, right? Thank you, beta.